Hi guys, so in the last video I showed you how to make these arrows move by modifying the transform component here, but you might have noticed that there were some issues in the last segment. So the issue I'm talking about is that when you set the distance duration here too low, the arrows will start moving in a strange fashion. So right now, yeah, let me set it to the way it was before the video here. So we used translate like that, and we're gonna start this. So yeah, what you will see is when you set this distance duration too low, it will start acting kind of strange and going off the screen and all that. And the reason is because once you start moving too fast, you won't be able to, this calculation won't be able to keep up. So what will happen is that in one frame, you'll have moved further than your waypoint. So it doesn't really matter if you're flipping, because transform the translate doesn't start from a point and go to a point, it just moves in a direction. So when you're doing transform and translate and you're saying, okay, move to the left, this will start moving to the left. It doesn't know where it's going, it just knows I need to move to the left at this speed. So then when you're messing about with this variable, this is gonna get all janked up. And because all we're doing here is really saying we're flipping the arrow that you're moving left or right, left or right. It's not actually aware of these positions at all. So there's a couple of ways you can fix that. So first of all, if you're supposed to be aware of the position, you can use something a little bit different than translate, because translate is supposed to be move towards, move in a direction, not knowing where you are supposed to go. But since we know where we're supposed to go, what you can do is you can use something called vector to the move towards, which is aware of where you're moving. So what you would do is you would say, okay, my current position is transform.position, that's my current position, and my target position is end position. And then our speed is our speed again, and we don't actually need this move direction at all. And then it's as simple as saying transform.positions equal move. And voila, that should resolve that issue, because now we are aware of where we're going. Yeah, there you go. So that works as you would expect. It's moving a bit strange, but there you go. Now we're aware, so it works properly. One more thing is you can use lerp, which is always aware of where it's going, because lerp is simply an interpolation between 2 points, right? So there's point A to point B. So if we're using the lerp, you will never ever overshoot, except if your lerp factor is greater than 1 or less than 0. Then you will not be at the position you expect. So that can't happen with our program here, because we are resetting our time every time, so it can't actually be greater than 1. But well, actually it could be slightly greater than 1, I guess. But what I usually do to make sure that this lerp is between 0 and 1, which is what you want in most circumstances, is to use the clamp function. Use the clamp of 1, and then you set it to the lerp. So this will make sure that lerp is always within 0 and 1, so that issue can never happen. So that means that if you want to move stuff at high speeds now, that should be fine. There's no more issues where it's gonna go outside of your screen or act weird in many other ways. You make it move like this, blah blah blah. Doesn't really matter. Yeah, so I just wanted to correct that in the last video, that there are some common issues that you can stumble into when you're moving and using time to flip. There are some other improvements you could make to this code, of course. For example, this thing is not, these methods are not aware of this, but they still have a dependency on each other, which is a bad idea. You wouldn't want these guys to have a dependency on each other if it's implicit like this. You want it to be explicitly defined that I depend on this guy working as expected. So one of the things you could do is make a new method that takes care of all the movement stuff. So for example, what you could do is move loop. It's you could even improve this even more, but what you could do is just do something like this. Start time is also gonna be there. Whoops. And it doesn't matter, because for us, because our method is, you know, it's just gonna be extra boilerplate code pretty much. But if you wanted to have more stuff in your update function, it might be nice to just have them separated in such a way that it doesn't get confusing when you're writing more and more code there. Yeah, so that's really all I wanted to cover. I hope you learned something and that this makes more sense to you. I really recommend that you play around with movement and the different ways. There's many ways of movement that I have not discussed, especially regarding physics and rigid body components. So you can explore that if you want. And yeah, thank you for watching.